All right, let's get started on the Quizizz review. Question 1 here. A rectangular garden is 45 feet wide and 70 feet long. On a blueprint, the width is 9 inches. Identify the length on the blueprint. So we have the actual is 45 feet wide and it is 70 feet long. And we have the model is, well, let's see. The word is width is 9 inches, 45 feet wide, so it is 9 inches wide because that corresponds with the 45 feet. So they want to know what is this piece down here. I'll call it X, right? Another way to think of it is model to actual, okay? In the model, 9 inches goes with 45 in the actual, right? So how many in the model? X goes with 70 in the actual, right? So a way to do this, and I'll use my handy dandy calculator. 45 times x is 45x equals 9 times 70. I can do that. That's 63 with a 0 at the end of it. So now I have to divide both sides by 45. Divide both sides by 45. I get x is equal to 630 divided by 45 equals 4, oops, equals 14, right? So the answer is 14 inches. Another way to think of it, and I'll change the color up here real quick. This times 5, 9 times 5 gives me 45. So what number here would replace x that if I multiply that times 5 would give me 70? And the answer is 14. 14 times 5 is 70. So the answer is 14, any way you look at it. Let's do the next problem. Question 2. The triangles shown are scale copies, similar figures. Find the missing side length. Okay. Well, let's go with corresponding sides here. 6 corresponds with 18, right? And this missing side goes with this side over here, right? Now, I could have also used 8 and 24, but I'm going to use 6 and 18, not 8 and 24. So we have, I'll call it the small to the large, okay? So the side on the small that is 6, that corresponds with, it goes with the side that's 18, just like the side that we don't know, so I'm going to use a variable here. I'm sick of using x. I'm going to use y. Y goes with the side with the large, that is 21. So by doing that, you should be able to see 18 times y is 18y. 6 times 21 is 126. Right? Let's make sure for those who don't believe me. 6 times 21, 126. Look at that. I'm going to divide both sides by 18. And I get y is equal to 126 divided by 18 equal to 7, which means the missing side is 7 meters. Now, listen, I went through the math, but I just want you to see logically how you can get that. From here to here, you multiply by 3. I should use a different color. times 3. From 6 to 18, you're multiplying by 3. So what number times 3 gives me 21? Once again, it is 7. All right, so you, you can do the math, but I want you to also pay attention to whether it logically makes sense. All right, let's go to the next question. Scale drawing of a car length is 3 centimeters. If the scale is 1 centimeter to 4 feet, what is the actual car length? So we have model or drawing, but I'll call it model, to actual. Okay. We know that in the model, 1 centimeter corresponds with 4 feet in the actual, right? And we know that in the drawing, in the model, it's 3 centimeters, and we want to know what is the actual. So I'll use X, I'll be lazy. Right? If you do the cross products here, you're going to see 1 times X is X, 4 times 3 is 12, so 1 goes with 4, like 3 goes with 12, meaning that 12 feet is the actual length, which should make sense because if it's 1 centimeter, goes with 4 feet, well, 3 groups of 1 would be 3 groups of 4, which is 12 feet. Let's move onward. In the model of a flagpole, 1 inch equals 4 feet. If the pole in the model measures 12 inches, how tall is the actual? So once again, this is a model to actual comparison. We know that 1 inch in the model corresponds with 4 feet in the actual, right? And it says if the pole in the model measures 12 inches, so in the model, change colors here, 12 inches in the model goes with, I don't know, well, let's see, let's call it T for how tall it is, right? Do the work here, you get 1 times T is T, 4 times 12 is 48, which means it would be 48 feet tall. Number 5, Blueprint was using a scale of 3 centimeters equals 4.5 meters. Find the actual length if it is 5 centimeters on the drawing. So our scale, model to actual, we know that 3 centimeters on the model goes with 4.5 meters in the actual world. Find the actual length if it is 5 centimeters on the drawing. So, and the drawing is 5 centimeters. We need to find the actual. So I'm going to call this A for actual. I'm just trying to show you guys that you can use a variable other than X. 3 times A is 3A. 4.5 times 5. We'll get our calculator for that. Feeling lazy today. 4.5 times 5 is 22.5. So divide both sides by 3 to get A by itself. Oops. Sorry about that, folks. So I get A is equal to 22.5 divided by 3. 22.5 divided by 3 is 7.5. So what does that mean? If 3 centimeters in the model goes with 4.5 in the meters in the actual world, well, 5 centimeters on the model would go with 7.5 meters in the actual world. Let's move on. Scale, 1 inch equals 7 feet. The actual width of the backyard is 49 feet. How wide is it in the drawing? Well, model to actual. All right, we know the scale is 1 inch in the model, goes with 7 feet in the actual world. All right. So it says the actual width of the backyard is 49 feet. So 49 goes here, right? How wide is it in the drawing? Well, we don't know in the drawing how wide it is, so I'm going to put D here as my variable. Why not? We can call it whatever we want. 7 times D is 7D, equals 1 times 49 is 49. Divide both sides by 7, and I get D equals 7. 49 divided by 7 is 7. So 1 inch goes with 7 feet in the actual world, just like 7 inches goes with 49 feet in the actual world. So 7 inches is our answer. Moving onward. Triangle ABC is similar to triangle FGH. What is the value of X in centimeters? So we're going to use a couple different colors. All right. I, I just kind of want to show you here. These two sides that aren't the straight length here. You can tell this side corresponds here. But this side that's 9 is shorter than 12, which means 9 corresponds with 13.5 is shorter than 18. So this is kind of like a mirror image and a scale factor. It's kind of not drawn exactly in the same position as the original. So this side that's 9 goes with this side that is 13.5. Those are the corresponding sides. All right. Now we need to find this length here. Well, G to H. Well, G to H goes with B to C. Now, something you might not have learned yet, but I'm just going to point it out. AB is the first two letters here. If somebody tells you the triangle ABC goes with FGH, well, AB would have to go with FG. And if you take a look, AB goes with FG, just like I described. And this side here, GH, second letter and third letter, GH would go with BC, the second letter and the third letter. Well, BC. All right. So, what do we have here? We have the side that is 9. So I'm going to call it small triangle to large. Small to large. So the side that is 9 in the small triangle corresponds with 13.5 in the large triangle. Just like in the small triangle, the side that is 15 corresponds with our variable there, x. So, no shame in using a calculator to help us out in a problem like this. 9 times x is 9x equals 13.5 times 15. So 13.5 times 15 equals 202.5. Divide both sides by 9 to get x by itself. So you get x equals 202.5, already there, divided by 9 equals 22.5, just to show you. Yep, 22.5. So the answer is 22. Oops, that was interesting how that happened. 22.5 is the missing piece. That's the piece that was that corresponds with 15 in the small, 22.5 in the large scale copy. Question 8. The triangles shown are scale copies, similar figures. Solve for x. All right. Well, if you take a look, this side here, the red side, 4 goes with x. The side that is purple here, 11, goes with 44. And let's go with blue. The side that is 13 here goes with 52 there. All right, so I'm going to go with, this one's actually larger, so large to small. So the large triangle, the side that's x goes with 4 in the small triangle. And the side that's, let's go with the purple, I like these numbers here, 44 in the large triangle goes with 11 in the small. Alright, so let's do our little math here. 11 times x is 11x equals 4 times 44. 4 times 44. 176. Divide both sides by 11. And you get 176 divided by 11 is 16. So x is equal to 16. Now, I just want to point out, if you take a look here, to go from this triangle to this triangle, 11 times 4 is 44. To go from this side right here, the blue side to the blue side, 13 times 4 is 52. Well, this side to this side is also 4 times 4, which is 16. All right. I know I got into the math, but I think it's important to see the proportions and how they're related to calculating this stuff. All right, question 9. The diagram shown represents a garden. The scale is 1 centimeter for every 20 meters. Find the actual area of the garden based upon the drawing. This is important. This is a little tougher. Okay. All right, we have model. And I'm actually going to draw a rectangle for the actual garden, because we're not actually asked to just find a side, we're asked to find the area. So this is a little bit more work. So the side that is 7, and this side is 2.75, right? Now the actual, this side is, we don't know, and this side, we also don't know. But we know that 1 centimeter, so 1 centimeter is 20 meters. So if I were to figure this out, 1 unit here is 20 times more than that, so 7 times 20 is 140 meters in the actual world. By the way, these are centimeters. Now, this side, 2.75, well, this is going to be 20 times bigger in the actual world, or the number is going to be 20 times bigger. The units are already bigger. 2.75 times 20 is 55 meters in the actual world, right? But that just gives us the side length. We were asked to find the actual area. Well, the area of a rectangle would be length times width, so we would have to do 55 times 140. 55 times 140 gives us an area of 7,700 square meters. All right. Once again, just want to show you that the proportions can be used to get you these sides. If I go model to actual, 7 in the model goes with a number we didn't know originally, so I'm going to call this x. Right? Just like our scale, 1 centimeter in the model goes with 20 meters in the actual. And if I use the proportion method to find this side, I can get 1 times x is x, 7 times 20 is 140, so I would have gotten this side length using my proportion anyway, right? And the same thing would have happened here. If I used 2.575 in the model, goes with a number we don't know, I'll call this y over here, y in the actual, gives us a scale of 1 to 20. You would see 1 times y is y, 20 times 2.75 we already did before, but I'm going to show you again. 20 times 2.75 gives us 55 in the actual, so we would have gotten this side length here, 55. All right, so however you do it, as long as you're getting these right, you know, we're okay with it, but I just want you to see proportions will always help you get the answers as long as you set them up. Model to actual, model to actual, model to actual. All right, let's move on to the next question. Question 10. The triangles shown are scale copies, similar figures. If the scale factor is 4, what is the length of x? All right, well, I know it's hard to read right here, but this side here is 4, and this side here is 16, so looks like the scale factor is from this to here, so 4 times 4 is 16, right? So if we are looking for x down here, x corresponds with this side up here, which is 6, kind of covered that. So I have to take this side and multiply it by 4 to give me this side, which is 24. So 24 is the scale factor. All right. Another way, I'm just going to show you with the proportions. Just if I go with the small to the large, 4 units on the small, this side, goes with 16 units on the large, that side. Just like 6 units on the small goes with x, right? So just a different way of doing the problem, but if you're setting up the small triangle to the large, the side that's 4 corresponds with 16, the side that's 6 corresponds with x, and you will see that it will work out. 4 times x is 4x. 16 times 6, 16 times 6 is 96. Divide both sides by 4, and you're going to get x equals 96 divided by 4 is 24. Same answer we got the other way. Let's move on to question 11. Robbie made a scale drawing of his neighborhood park. A soccer field in the park is 14 inches long in the drawing. If the actual field is 98 yards long, what is the scale of the drawing? So we know that this is drawing or model to the I really have the handwriting of a 5-year-old. Drawing to the actual. So we know that 14 inches in the drawing goes with 98 yards in the actual world. And it says, what is the scale of the drawing? So if it's 1 inch in the drawing, we want to know how many yards, I'll use x, in the actual world, right? That's our scale. 14 inches goes with 98 yards. 1 inch would go with how many yards? So do our little handy dandy math here. 14 times 1x is 14x equals 98 times 1 is 98. Divide both sides by 14, and I get x is equal to 98 divided by 14 is 7. 7 yards for every 1 inch, which should make sense because 14 inches would be 14 groups of 7, which is 98 yards. So there we go. Question number 12. Augusta made a scale copy of the following quadrilateral. She used a scale factor less than 1. So we'll talk about that means in a second. What could be the length of the side that corresponds with AD of the scaled copy of the quadrilateral? So it's kind of small here, but this side is 1, 2, 3, 4, 5, 6, 7 units in length, right? So this side is 7 units in length. Well, the scale factor, 7 times my scale factor is going to be the corresponding side elsewhere. Well, this is 7 times a number that is less than 1, right? So if I take 7 and multiply it by a number less than 1, I'm going to end up with an answer that is less than 7. Right? So we are looking for 2 answers that are less than 7. So that's not less than 7. That one is less than 7. This one is less than 7, not less than 7, not less than 7. So the answers are 2 and 3.5. Those are the only ones where the corresponding side is less than 7, the original side. Let's move on to question 13. Aria made a scale copy of the following triangle. She used a scale factor greater than 1. What could be the length of the side corresponding to the one that measures 10 units in her original triangle? So we have this one, which is 10 units. So 10 times scale factor greater than 1, which means our result is going to be bigger than, it's going to be bigger than the original. So it's going to be bigger than 10. So we want to look for two answers that are bigger than 10. Well, that's not bigger than 10. That one is. That one's bigger than 10. That's not bigger than 10, and that is certainly not bigger than 10. So by taking 10 and multiplying it by a scale factor greater than 1 means you're going to end up with a side that is greater than our original here, which is 10. Moving on to question 14. Figure A is a scaled image of figure B. Figure A maps to figure B with a scale factor of 0.25. What is the value of x? So I know this is really hard to see, but if you did it on the problem, you would see that this is 1.5 over here, and this is A to B. So this side here is 1.5, and this side here is x. All right, so we know this times 0.25 would give me that, right? So x times 0.25, I'm going to write it as 0.25 times x, multiply that times x gives me 1.5, right? Well, if I divide both sides by 0.25, I'm going to get x is equal to, I'm going to do it with a calculator, but show you don't have to do it with a calculator. Divided by 0.25, you're going to get 6. So if this side here is 6 units, let me put that in red, 6 times a fourth, or 0.25, would give me 1.5. So it got smaller. That makes sense because we used a scale factor of 0.25, less than 1. Another way to think about it is, this is a quarter, right? This is like $1.50. Well, how many quarters does it take to get $1.50? Well, 4 quarters and $1 plus 2 more to make 50 cents. 4 plus 2 is 6. So could have done it without a calculator, but just wanted to show you. This side length is 6. And question 15. Figure A is a scale image of figure B. Figure A maps to figure B with a scale of 2 over 7. What is the value of x? All right, so let me zoom in because I don't remember off the top of my head what this number is. 12. Okay, so we'll zoom back to entire page 12. All right, so this is 12, and this one here is x, right? And it's A to B. Let's make this bigger again. So this is A, and this is figure B. All right, back to reality size. All right, so from A to B is 2/7. So we have this times 2/7 gives me 12. Well, 2/7 times x gives me 12. Well, I need to now solve for x. So I'm going to multiply this side by 7 over 2, which gives me just x. This side times 7 over 2. If you think about it, this is 12 over 1 times 7 over 2. I can simplify 12 and 2 to 1 and 6. So I end up with 42 over 1, which means the side length is 42. Once again, this is a scale factor less than 1. So if I take 42 times a number 2/7, I'm going to end up with a smaller number, which is 12. All right, hope you found this helpful.